What would it take, really, to make a computer conscious? What makes you and me conscious? There have been a number of approaches over the years to building a conscious computer. One is mimicking the brain, or at least the way we think the brain works, with neural networks and learning algorithms. Another is by imposing complexity on our computing systems and giving them feedback. Another approach is to use quantum computing with qubits. An approach that's very much in vogue right now is using artificial intelligence. But the issue with something like artificial intelligence is that we know it can mimic what a conscious being does, but it lacks the consciousness characteristics themselves. And we'll talk about those in a moment. So all of these approaches are missing a characteristic of consciousness. What I want to do here is not only give you my opinion of how consciousness can be brought into a computer, but also show you some data to show that, in fact, this looks like it is right. And at the end of the talk, let's see if you agree. Okay, so back to the characteristics of human consciousness. So we can say there's a sense of self, there's intentionality, we want something to happen, there's a sense of meaning in what goes on all around, there's a correlation with the function of our brain. But what else is there? Well, the consciousness is extended. It extends beyond what is in here and connects what is in here with what is out there. And in this way, it's very much like psi phenomena. So let's take a moment and talk about psi. So psi or psychic phenomena include psychokinesis, being able to affect random systems using our intention. It involves also information transfer. So that's telepathy to another person, clairvoyance, where we know something beyond what would normally be in our knowledge sphere. In its applied form, it's remote viewing, precognition, anticipating the future. The issue with a lot of these phenomena is that there's a lack of acceptance in the scientific literature. But this lack of acceptance is due to ignorance of the literature. It's not due to lack of evidence. There's a huge amount of evidence. A recent paper was published citing 750 discrete studies. These are peer-reviewed, carefully carried out experiments showing the existence of these phenomena. There are many books that have been published over the last 100 years. Here I show three. And there's also our own experience, our own spontaneous experience, which is certainly substantial. So, psi phenomena involves non-local interactions. So that is a transfer of knowledge over distance, a transfer of action over distance, and also over time. And this is something where living systems receive and transmit this information. The psi characteristics are the interaction between a conscious being and another conscious being, or a physical entity, such as in dice or something like that, or some source of knowledge which we have access to. But what it is not is interaction between non-conscious entities. Therefore, we can say that consciousness is embedded with psi phenomena. And a key characteristics of consciousness is psiability. So how are psi signals carried? For quite a while, there were models that they might be electromagnetic or carried by some other physical waves. A problem with that is they'd fall off with distance, which would mean you'd have to have a huge signal strength in order to carry them any significant distance. Faraday cages have been used to carry out experiments. They block electromagnetic fields, but it doesn't block psi interactions. There's no evidence that micro psi phenomena carries energy. And a key characteristic here also is that psi travels both forwards in time and backwards in time. So these physical waves just don't really make sense. Then there have been arguments that perhaps it's quantum entanglement. Well, entanglement, as we know, carries correlation, not causation. And as far as we think, psi phenomena are causative. Now, maybe that will change as we understand more. But basically, we can say that these signals, the nature of these signals and how they're carried is unknown. But we can say something useful about the nature of these signals in understanding the question, can we control a deterministic system? If we've got a set of intermeshed gears, can we use consciousness to shift them? Well, that would take energy to modify, and psi phenomena carries no energy, and therefore it cannot affect a deterministic system. So what we really need is a random system. We need a system in which what's going to happen is unknown so we can influence it. So how does nature produce randomness? One way that we can think about randomness is through fluctuations. Fluctuations, vibrations, noise. So this noise can be thermal, that is from thermal vibrations, it increases with heat, or it can be quantum fluctuations, which is also called zero-point energy. And without noise, there are no possibilities of psi interactions with physical systems. So this was realized and used by a number of people, including Helmut Schmidt, who in the early 70s developed his electronic random number generator. It used quantum noise, and he used it to carry out a number of psychokinesis experiments. He's shown here. It's with tossed coins, which are susceptible to noise and vibrations of air and the table they fall on, rolled dice, and so on. And there are hundreds of research systems showing where these random systems are the receivers, and these are inanimate systems. Now, what about in living systems? Well, in living systems, I was surprised to find in 2013 that neurons in our brain sometimes produce noise. In particular, I read a paper about our optic nerve and how it introduces noise. There are some elements that do nothing but introduce noise. Why would you want to do that in a system that you want to be quiet and accurately carry a signal from the eye to the brain? Well, I presented a talk uh, asking the question whether these neurons, these noisy neurons, were actually psi receptors. They were receivers for noise and were a way that this psi signal entered the brain. So now there have been a number of more of papers showing this and showing in particular that noise is produced in nearly every cell in the body, not just in these optic nerves and so on. Not only that, but the neural signals in the brain are stochastic in nature. That is, they're statistically random. So there's a lot of evidence that we in our brain system have interaction with noise. So we ask the question, what then is the receiver for psi, where psi can include telepathy, clairvoyance, clairsentience, where we feel things that from a distance, the applied remote viewing. And the receiver, the transducer elements, are noisy neurons and other cells in our body. So psi somehow imposes order on the noise. For example, for an electronic random number generator, it may shift the randomly produced zeros and ones to produce more zeros or more ones. So we can also ask the question, what is the transmitter in living systems for psi? The transmitter to send, for example, psychokinesis effects to physical systems or to send signals to other living systems through telepathy. And what is the transducer? What is the element that that produces the signal that's sent? And I don't know. It's really not known. We may get a clue from the fact that in a number of physical systems, the same element that is a receiver is also a transmitter. There's a reciprocity there. Maybe it applies here, and the noisy neurons are somehow transmitters as well, but I don't know how. Okay, so we know that the A function of noisy cells is quite possibly being psi receptors. Okay. That somehow links the extended consciousness of psi to the brain. And so we can make a postulate. And the postulate is that in living systems where psi is a characteristic of conscious systems, noisy neurons are required for conscious life. Okay? That's postulate one. Then we can go a step further and make a postulate for computers and say that for computers, noisy elements are also required there for conscious computers. So has this been demonstrated? Actually, it has. So in 2018, I gave a talk called An Introduction to Cybotics, in which cybotics was a term that we developed to describe the use of our intention to affect a physical system. And we could make some sort of a robotic system which we programmed using our intention. And we demonstrated it. And I'll talk about that in a minute. More recently, Mark Boccuzzi has developed a cybotic system called Throne of the Sphinx, and he's gotten some very interesting results with it. So one example of a cybotic system was for the Princeton Engineering Anomalies Research Lab, where they made a little mobile robot that was on a table, and it had an electronic random number generator in it that determined the direction of motion. An observer could intend for it to move in a certain direction, and the Pear Lab found that, in fact, there was a statistically significant motion of that little robot in the intended direction. Another cybotics example is the Celeron mind lamp. This was a lamp which had an electronic random number generator that determined the color that it produced. And I had this and loved playing with it until it broke. Unfortunately, they're no longer available for purchase. I really wish they were. Another example is the following bomb detector that I measured with a group in 2006. It consists of a sort of a gun holder-like thing with a pivoting antenna connected by a wire to a box which was virtually empty. It had elements of something, but nothing was electrically connected to it. And we measured it in Colorado and found that well, let me tell you actually, in Iraq, where it was used, people found that it was actually very useful, and they would purchase it for an exorbitant fee. They were like $20,000 or more. And it's essentially a fancy dowsing rod. And so you can then say that this and dowsing are examples of cybotics, where we use our intention with a physical element to carry it out. Another example was an electronic random number generator predictor that my lab worked on in 2010 and 2011. What it consisted of was an electronic random number generator that through a computer shut off a second random number generator at an arbitrary time. That second random number generator was spewing bits into the computer, and what I wanted to know was would the electronic random number generator here anticipate its own demise, and perhaps before it was being shut off, would it change the bit stream that was being sent to the computer? It was built and tested, and here's a result. We showed in this case, after 1,730 trials and control trials, that the average bit rate hummed along randomly until about 1 second before the random number generator was shut off, and it made a dramatic change, producing more zeros than ones. So this essentially was a cybotic system. Another example was what we developed called machine-mediated remote viewing. So using this, we had a subject doing a standard sort of remote viewing where they were drawing a target that they'd been tasked to draw, and that target was an image hidden in an envelope. In this case, it was a Zener card. And at the same time, we put an electronic random number generator in the room. The remote viewer didn't know it. That random number generator produced a bit stream that was collected by an adjacent computer. The computer later produced a raster scanned image from the electronic random number generator. Then we had judges who judged both the image drawn by the remote viewer and by the image drawn by the computer and decided which of the 5 possible Zener card images they thought it was. And here's an example of one of the tests that we ran in which the remote viewer drew this and the computer produced this. And both of these were independently tested by the judges. In both cases, the judges said that they thought it was most likely a wavy line, and it turned out it was a wavy line. Okay, so have we built a conscious computer? Because we've now made these cybotic systems. Well, yes, but our cybotic systems have only one noisy neuron, and that was the electronic random number generator. A brain has 100 billion neurons. Each one of them is noisy. So we're far from that. So how would we introduce noise into a computer? As you know, binary logic, which is used in current computers, is designed to be invulnerable noise. So to introduce noise, we'd have to use noisy, less reliable circuitry, or incorporate many, many electronic random number generators, or perhaps build an analog computer which uses analog noise. So if we did that, would that be enough to build a conscious computer? Is it sufficient to introduce noisy neurons? The evidence seems to say it's necessary, but I don't know whether it's sufficient. This reminds me of the well-known example of the Dalai Lama visiting Bob John at the Pear Lab in Princeton. And after the tour of the lab, as he was leaving, the Dalai Lama asked Bob, was there a question that Bob had for him? And Bob said, yes. Would this electronic random number generator, would this be conscious? And the Dalai Lama thought, and he said, if you think it's conscious, then it's conscious. So there's something there about imbuing consciousness to a system. What does that mean? And if a computer is conscious, is it then a node in a universal consciousness? Is it connected somehow to the mothership? And how would we know if it's conscious and not just mimicking consciousness? That's an easy one. It would be able to perform psi and act as a psi receiver of intention. We've already seen that in our cybotic systems, and presumably, if we built a cybotic system which had many, many random elements, then it would work both as a psi agent and as a psi receiver. So you might wonder if I'm making an underlying assumption in what I'm proposing in this video. That is that there is both a general consciousness, as in the philosophy of idealism, in which the universe is fundamentally mental, and also a physical reality, as in materialism. You might think that combining them leads to a sort of dualism. But even if we accept idealism, even in idealism, you've got to admit that what we perceive as physical reality is extremely persistent and it's highly consistent. So even if the universe is an idea, a simulation, if you like. It must include the means to connect what we perceive as the physical to what we perceive as the conscious. Thank you, and be well.